So today we're going to talk about rational functions, graphing them. And so all of the practice we've been doing with simplifying and adding and subtracting, multiplying, dividing, all of that good stuff, we're using. So when we were factoring, we're still factoring both the numerator and the denominator. And we are also going to be using those excluded values that we discussed when we were simplifying. So we have to look at many different parts of our rational functions. We have to look at our intercepts, our x-intercepts. So for the x-intercepts, we're going to factor the zeros of p of x. P of x is just a fancy way of saying the numerator. So we're going to factor the numerator and solve. Okay. Then we are also going to need to look for our asymptotes. And if you remember, we talked about those during our parent functions discussion at the beginning of the semester. So to find the horizontal asymptotes, the vertical asymptotes. Let's skip down to the vertical asymptotes so we can stay on the same board. The vertical asymptotes we find when we factor the denominator and solve. So Q of x is just function notation to represent the denominator. So for the vertical asymptotes, we're looking at the denominator. So factor the denominator and solve. Okay. Then for the horizontal asymptotes, it's a little different. Okay. We have to compare the degrees of each, the numerator and denominator, and look at the chart or refer to the chart. Okay. All right. And by the chart, I'm talking about this chart right here. So this chart is how we find our horizontal asymptotes. Okay. So the degrees, remember, are the largest exponents in a polynomial. So if the degree of the numerator is less than the degree of the denominator, our horizontal asymptote is at y equals 0. If they are equal, then it is the ratio of our leading coefficients. Okay? And then if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Okay? So let's practice looking at all of these things. To find the x-intercept, remember we said we're going to factor the numerator and solve. Well, our numerator is just 5. There is nothing to factor. So we don't have any x-intercepts. In fact, if we were set it equal to 0, we would just have 5 equals 0, which doesn't make sense. So there you go. 5 x-intercepts, there are none. Okay. Then we want to look at the horizontal asymptotes. That's the next best thing to look for. Sorry, the vertical asymptotes. I keep saying it wrong because that's factoring the denominator. So look at our denominator here. We have x plus 1 times x minus 1 because that is a difference of two squares. So that means x plus 1 equals 0, x minus 1 equals 0. That means we have a vertical asymptote at x equals -1 and at x equals 1. And so the vertical asymptote is a horizontal line that goes through the x values of -1 and 1. Those are our vertical asymptotes. Okay. Then we're going to look at our horizontal asymptote. So remember, we're going to compare the degrees, okay? So for the horizontal asymptote, I have a degree of 0. This is the same as having x to the 0 power here. So my m, if we're referring to the chart, is 0. So to find the horizontal asymptote, we will look at our degrees. So we have x to the 0 and x squared. So 0 and 2, 0 is less than 2. So when we come up here, it tells us that y equals 0 is our horizontal asymptote. So that is an invisible line that goes horizontally through y equals 0. And that is all of our parts. Looking at our next example, we have x squared minus 9. So that's a difference of 2 squares that factors into x minus 3 times x plus 3. And we have the denominator, which you can factor. And once you have factored, you will get x minus 5 times x plus 3. So we have 2 factors that divide and give me 1. Okay? Now, when I am looking for my x-intercepts, I will look at the factor that is left. Okay, so x minus 3. Set it equal to 0 and solve. So I have an x-intercept at x equals 3. Okay? To find my vertical asymptote, I will factor the denominator, which is already factored, and I have x minus 5 left. So I will set that equal to 0 and solve. So I have my vertical invisible line at x equals 5. Then for my horizontal asymptote, I have to look at my degrees. So I have a degree of 2 and a degree of 2. Those are equal. So when I have equal degrees, that means the line y equals the ratio of my 2 leading coefficients. So what are my leading coefficients? 1 and 1. So I have y equals 1 over 1, which we know 1 divided by 1 is 1. So I have a horizontal asymptote going through the value of y equals 1. Now we have to talk about something we have not talked about yet. So if you remember, we had the x plus 3 that divides out. And when we were simplifying, we were still listing this as an excluded value. And the reason is because we have a hole in our graph with the factor that divides away. So I will set x plus 3 equals to 0, and that gives me negative 3. So I have a hole in the graph at x equals negative 3. Once I find all of these parts, then it is simple to graph these functions. So now it's time to put all of the things we just spoke about to use. Okay, so I want to find all of those critical features that we just discussed before I put my function on the graph. So the first thing we did was we found the x-intercepts, right? By setting the numerator equal to 0, which is 8. So that doesn't make sense, and that means we have no x-intercepts. Okay, so done there. Check that off our list. Then we want to look for our vertical asymptotes. The vertical asymptotes, remember, if we factor and solve the new denominator. So if I factor the denominator here, that's going to be x minus 3 times x plus 2. All right. So for my vertical asymptote, I'm trying not to get them mixed up. I have x minus 3 equals 0 and x plus 2 equals 0. So that means I have horizontal asymptotes at x equals positive 3, x equals negative 2. All right. Vertical asymptotes. That is vertical, an invisible vertical line through x equals 3 and through x equals negative 2. Okay, so this is a good indicator. So our graph is going to be split up into 3 sections here. Okay, found my vertical asymptotes. Now we're going to look at our horizontal asymptotes. So remember, for the horizontal asymptotes, we are looking at our degrees. This one, remember, is the same as a degree of 0. This is a degree of 0 and 2. So the numerator is less than the denominator in terms of degree. And that tells us on our chart, when the numerator is less than the denominator, that y equals 0 is our horizontal asymptote. So I have a horizontal asymptote at y equals 0. So when y equals 0, that's right here. And so our horizontal asymptote is actually on the x-axis, okay? So we have a graph that's going to be either here or here, here or here, here or here, okay? All right, horizontal asymptote done. Holes. Holes are where we have an excluded value in the denominator that we crossed off, and we didn't have anything that we crossed off. So there are no holes. Okay. All right, now we're ready to put the graph on the coordinate plane. So what we need to find is where these sections of the graph are. So we're going to find points to the left and right of the vertical axis, okay? So my first vertical axis on the left is at negative 2. So I want to pick something to the left of that. And at negative 3 is easy. So we'll just pick negative 3. And just like we've done in the past, we will plug negative 3 in for our x values to get what y is. So that is negative 3 squared minus negative 3 minus 6. So negative 3 squared is 9 plus 3 minus 6. That is 12 minus 6, or 6. And it's actually, that's just the denominator. So it's 8 over 6, or 4/3. So we go 1 and 1/3 is our y value. So negative 3, 1 and 1/3 is just a little bit further. So now I know this graph cannot go any further than the x-axis because that's an asymptote. It cannot go any further right than this vertical asymptote. So it looks something like this. Okay? All right, so that's that section, and there's nothing down here. All right, well, so for the next section, I'm going to look at this section in between these two vertical asymptotes. And 0 is super easy to plug in. So I'm going to pick 0. If I plug in 0 here, that goes away. Here, that goes away. I have 8 divided by negative 6. So that's a negative 1 and 1/3, since we've already had 8 divided by 6. I'm using that. So my point that I'm going to use is at 0, negative 1, and 1/3 a little bit further. So it cannot go above this, so it's going to look something like that. Then I have my third section that I'm going to look at. I need to go over here to the right of this asymptote, so I'm going to pick 4. So I have 8 over 4 squared minus 4 minus 6. So 4 squared is 16, minus 4 is 12, minus 6 is 6. So once again, I have 8 over 6, or 1 1/3. Just keeps popping up. So the point is 4, 1 1/3, 4, 1 1/3. And so it can't go below here, and it can't go to the left of here. So it's going to look like this. So this is my graph of my first rational function. All right, we are going to skip straight over to number 6 and talk about number 6. For all of my things here, I need to factor. So let's go ahead and factor this because I can tell there's going to be a lot to do. Okay, so I have a GCF in the numerator. I will factor that out, and I get this. So I can still factor that. Let's see what we have here. Here I have a 3, and I really don't like a negative for a leading coefficient, so I'm going to factor out a negative 3, which leaves me with x squared, and that's going to turn that into a minus 1. But there is still factoring to do. So I'm going to come down here. 1 times negative 2 is negative 2. So to factor the numerator, that trinomial, I'm going to have x minus 2 times x plus 1. And for my denominator, if you notice, I actually goofed. This is an x squared here. This is a difference of 2 squares, so I can factor this into x plus 1, x minus 1. So I'm negative 3 times x plus 1 times x minus 1. All right. And here I notice that I have 2 factors that will factor out. So that, if you remember from the first page of notes, is going to give us a whole right here. And we'll talk about that in a minute. Okay, so the x-intercepts are easy to find. We take our factored numerator and set equal to 0. So I have x equals 0, and I have x minus 2 equals 0, which is x equals 2. So x-intercepts I have at 0 and at 2. Okay. Now moving along to my vertical asymptote, I will look at my numerator. So my numerator is negative 3 times x minus 1, because this is my whole. We're not using that. Negative 3 equals 0 doesn't even make sense. So that's not a part of anything. And then I have x minus 1 equals 0. So that means I have a vertical asymptote at x equals positive 1. All right, vertical asymptote at x equals 1. So there's my invisible line that goes there. All right. Now I'm going to talk about my horizontal asymptote. So I have to look at my degree. So here I have a degree of 3, and a degree of 2. So this time I have my degree of my numerator is larger than my degree of my denominator. So we have no horizontal asymptote there. Okay? So none. So that means I'm going to have something over here, and I'm going to have something over here. All right, so holes. As I said before, this factor in the denominator crossed off, so I have a hole at x equals negative 1. Now, I cannot put that there yet because I'm not sure exactly where that's going to be, but we have to remember that at negative 1, I've got something special going on, okay? So now I'm ready to pick some points to the left and the right and see what happens. All right. So X, I want to go to the left. Oh, we already have one here, don't we? So let's actually pick another point that's not 0. And we're not going to pick -1 because that's a whole. So let's pick -2 just to give us a better idea of what's happening. If I pick -2, plug this into my function, it's going to be -2 cubed minus -2 squared minus 2 times -2, all divided by -3 times -2 squared plus 3. All right, so -2 cubed is a -8 minus 4 plus 4. So those go away, and I just have -8. -2 squared is 4. -3 times 4 is -12, plus 3 is -9. So when this simplifies, I have the point -2 and 8/9, which is almost 1. So -2, almost 1 here. Okay? All right. So my graph goes down, but it cannot go any further right than my vertical asymptote. And as you can see here, this is going to go off pointing towards the left. So I'm going to draw it, but remember, there's a hole right there at -1, and then it goes something like that. Now let's go to the other side. So here I have 2. So let's pick 3 just for a double check. I like double checks. And I'm picking 3. So I have 3 to the third minus 3 squared minus 2 times 3, all divided by -3 times 3 squared plus 3. So 3 to the third, 3 times 3 is 9, that's 27 minus 9 minus 6 divided by 9, that's a -27 plus 3. So what does that give me? 27 minus 9 is 18, minus 6 is 12. 27 plus 3 is a -24. So that's a -1/2. All right, so the point 3, -1/2 is where I go. So 3, -1/2 is going to be right here. So what that means is, again, I'm going to go up, but I cannot cross this blue line. And then here I'm going to go down, but you can see it goes off in this direction. If my graph was a little better, you might see that it kind of is not crossing this invisible line. That's a slant asymptote. That's something you can talk about in your next class. Okay, one more example. So again, if we factor, we have, let's see, x divided by, 4x is my greatest common factor. So that leaves me with x squared plus x minus 2. And I'm just going to go down here. If I continue to factor, I have x divided by 4x times, and I have x plus 2x minus 1 as my factors. All right. So hopefully you notice the x's divide out, so that will be a hole there. And we're ready to move forward. So looking for my x-intercepts, that's my numerator. I'm not going to have any x-intercepts. So we could set x equal to 0, but that's also where the hole is. So that means that we can't put a point there. So we're going to say none. And then we'll look at our vertical asymptotes next. So that's our denominator. So we have, again, oh, I crossed out the wrong x's. That's confusing. So we have x plus 2 equals 0 and x minus 1. So that means I have vertical asymptotes at x equals -2 and x equals 1. So -2 is this way, and 1 is this way. It's a teeny tiny little section there. Now we are going to look at our horizontal asymptotes. So we have a degree of 1 here and 3 here. So 1 is less than 3. And our chart tells us if 1 is less than 3, then it is 0, y equals 0. Okay, so y equals 0 is the x-axis. So I will draw my invisible line there. So again, we have 6 sections that we have to find places for. Let's find our hole. So our hole was right here at x equals 0. So on the y-axis, I'm going to have a hole somewhere. Okay, so to the left of my first vertical asymptote, I've got -3. So if I substitute -3 in, you can use a calculator. I'm going to fast forward. If I substitute -3 in, I get 0.06. And if I substitute -4 in, I get 0.025. So -3.06 is right here, little. And -4.025 is closer. So remember, we can't cross this green line or the blue line. So it's going to go something like this. It's going to get very close, but not cross. For our middle section, I'm going to use -1. And so if I substitute -1 in, I get 0.125. And if I substitute, well, 0 is my hole. So let's just go with the -1. I have -1 and 0.125, so that's over here and just barely above there, which means I'm not going below the green line. So it's going to go this way up like a parabola, but just remember I have that hole there on the y-axis. So it looks something like that. And then for my last section on the far right, I'm going to use the 2 and the 3. And so I have 2 and 1/16. This is so small that it's hard to write the decimal. And 3 and 1/40. So very, very close to 0. So I'm going to be up here a little bit and then closer even. So it's going to look like the other side, but not cross the blue line or the green line. So number 8. Explain how to find the x-intercept of a rational function. How to find the x-intercepts. We factor and solve the numerator. How do we determine if a function has a horizontal asymptote? We look at degrees. So if the degree of the numerator is greater than the degree of the denominator, then the horizontal asymptote greater, I went backwards, there is no horizontal asymptote. No horizontal asymptote. If the degree of the numerator is less than the degree of the denominator, the asymptote is, or the horizontal asymptote is at y equals 0. If the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote is at y equals the leading coefficient of the numerator over the leading coefficient of the denominator. Then, how do you determine if the function has any vertical asymptotes? We factor the denominator and solve.